Okay, so today we're going to introduce a concept known as object-oriented programming. Pretty much all modern languages are object-oriented language, where essentially pretty much everything is an object. And again, that means a lot of different things that we'll explore over the next few days. But in practice, what we're doing with object-oriented programming is we're going to write classes to represent real-world objects and situations, and then we will create objects, or instantiate is the technical word we'll use. We'll instantiate the objects based off of these classes. We've actually been working with classes the whole semester. We just haven't written our own. So we're kind of starting to get a little bit underneath the hood, understanding how things work. So maybe just to give you a general example of like a scenario where classes are useful and why we want to be able to write classes. So classes are typically denoted with let me leave it like this. Classes are typically denoted with a capital letter, and the module in which they are written is a lowercase letter. So we worked with Turtle before. So from Turtle, we imported a capital Turtle. This capital Turtle is the class. And again, if you want to verify that, let me just go ahead and clear this. If we're in just the console, it's a REPL environment, we can go ahead and import Turtle. And if I were to go ahead and just type Turtle, it'll tell me it's a module. And a module is basically just a file that has in it a bunch of functions or classes. And then if I were to go ahead and just say like turtle.turtle, it's going to be a class. And then tied to a class are a bunch of attributes. For example, if you remember the turtle, once we instantiated it as Bob or something like that, we could adjust its color. We could tell it to do something. So it is like the color it is like if it was blue, that's an attribute. And then what we have right here are functions that are tied. Something that the object will do is a method. So again, you're going to hear me say things like attributes or methods a lot over the next few days. A attribute is like a property of the class, so its color, its shape, and a method is just a function that is tied to a class. So it's something the object does. So that's kind of the setup. The nice part is about classes is you have a template to create multiple objects. So so you can see right here, we have Bob, and then we also have Katie. They are both turtles, but they each have their own attributes. They each could do different actions that won't affect each other. So instead of having to basically do a bunch of for loops or reset or making a bunch of variables, a class is essentially containing all of that into some object. So with that, let's actually go ahead and write our first class, and we're going to just write one called dogs. Any dog people in here? So Caroline, I was a dog person, now I'm a cat person because I know how much work dogs are. But so let's go ahead get ourselves set up in REPL. And typically when you define a class, it's good practice to put it in its own file. So I'm going to go ahead and add a file, and I'm going to call it dog.py. So in convention, when you write a class, it's just kind of keeping things organized. It's nice to put it in its own file. You don't have to. You could go ahead and start it in main, but just keep in mind that it's good practice to have its own file. And maybe actually good development practice. Let's actually start in main because you'll find like, hey, as you're developing something, it would be nice to just kind of experiment, and then you'll refactor or clean up your code. So let's start in main. And what I'm going to do is to define a class, I'm going to type the word class. I'm going to name the class. It's going to be a dog, so capital D-O-G. And I'm not going to give it any sort of arguments. It's just going to be parentheses. So there's a lot of things that could go on in a class. We're just going to experiment a little bit right here. Whenever there is a class, you will initialize it and store it in some sort of variable. So if you initialize a class, maybe you like want some default setup. So what you will do is within the class, you'll define a function, and there's special functions within the class. One is the _init function. So init stands for initialize, and _ will sometimes be read as dunder. I think I've mentioned this earlier. So this is a dunder method. These are special methods or functions that you will define for your class. And this is a function that takes arguments. So here's the first thing that's going to feel a little weird. I'm not going to lie, it took me several weeks to actually understand when I needed this word and when I didn't. Self. Self is a keyword that basically is saying this is going to be attached to different attributes and message and say this is going to act on itself. So let's go ahead, and when you initialize a dog, you probably want to know a little bit about the dog. Let's say its name and its age. So, Caroline, do you have a dog? What's the name of your dog? Riley? Really? That was the name of my last dog. So, yeah. So we'll share pictures after class or something. All right. So these next few slides are good. So let's do it this. So I'm going to come down here a little bit, but we'll just call this my dog. It's a variable. I'm going to store into that a dog, capital D, with the name Riley, and age. How old is your dog, Caroline? 9. So it's still yelling at us because there's some indentation. We still have to fill out what this function does. So what I'm going to do is I'm going to go ahead and essentially the information I'm passed in needs to be stored into this class. So I'm going to say self.name, the name of the name of this initialized dog is going to be the name that I pass in. So, and then the age of the initialized dog is going to be the age that I pass in. So essentially, So let's go ahead and run this, and nothing's going to happen, but let's just make sure we haven't messed anything up. Okay, so that's good. But what we can go ahead and do, let's go ahead and print my dog and put a dot. The dot operator will access the methods and attributes of the class, and I'm going to go ahead and do name. So if I hit run now, you can see it printed the name Riley. So, and just I'm going to comment this out just to kind of show you that like this is all happening. I'm going to go ahead and just print just to show you like this is actually happening. I'll just say dog is being initialized. There we go. And if I hit run, and notice before it did nothing, but it is doing the initial setup of the class. So again, this was implicitly called whenever you initialize a class. So again, right here, what I'm doing is I am initializing a dog and storing it in my dog. Bless you. So does everyone kind of have a little bit of an idea of how things are happening here? Yeah.
Why did we use self?
So, and that's something that we're going to go ahead and learn a little bit more about as we go, because anything, so let's go ahead and, what do dogs do? I think we need an example. So like if Caroline, like if you were playing with your dog, it wanted a treat, what would you tell it to do? Sit. Okay, so that's something it does. That's an action. So let's go ahead and define within the dog class, it should be able to sit. So let's define a function, and again, a function in class is just called a what? Did anyone remember what I've been saying? A function in class is called starts with an M, M-E, method. So a function, so if you hear me say method, I'm just referring to a function that is tied or defined inside a class. So I'll say right here, maybe just to add some context, this is an attribute. This is also an attribute. And this right here is a function. And So anytime you're defining a function within within the class, you're going to need to pass in self. And this is kind of getting to what your question is, Alejandro. So self, whenever you pass it into a function in a class called a method, this function now has access to all of the attributes of the class. So for example, we want this, of course, we don't want to hard code Riley into this one, even though I'm sure she is really cute. What we need to go ahead and do is let's put a doc string, and we'll just go ahead and simulate a dog sitting in response to a command. And what we'll just simply do is we can go ahead and print. Let's go ahead and do it like this. Let's do this in F string. And we want the name of the dog. So this is where it's going to be a little bit weird. This is where you need self. Because notice I haven't said the name anywhere in this function. So if I do self.name, and we'll just say is now sitting. So we basically simulated it. So how do I call a function? So what we'll do is do my dog and dot to access the class. And we'll go ahead and call the sit function or sit method. And let's go ahead and run this. So you can see the dog was when my dog was stored, or when dog was initialized and it was stored in Riley, that's when this happened. So if you want to, you can always comment that out. We kind of proved that point. And you can see right here, we called this sit method and this code executed. Just to kind of see the importance of self, notice if I take out that self.name, is giving us an error that says undefined name. And that is because the name that is the attribute of this dog is not available in general. So basically the arguments you pass in, Riley and 9, are only going to be seen by the init class. So that's what the self is doing. If you try running this, you're going to just get an error because this sit function does not know what the name of the dog is. Yeah, Anna.
And that works within the whole the class, so it can access every single thing.
Yeah. So for example, like if we did not put sit right there, or if we did not pass in self.
So it's not an argument.
It is kind of an argument. It's definitely something that's happening with class. Sit is a function that you need to pass in the self, and self is a special kind of variable within a class that is allowing you to pass around attributes. Yeah, it's a tough concept, so it's going to take us some time. Like I said, I did not get the first time I did, so we're going to do several examples. Yeah, Alejandro.
And we have to use the word self.
Yes. Yeah, other languages use, like JavaScript uses this. An older language like C does not even have object-oriented programming. You have to pass around structs. So yeah, it depends on your languages, but the word that Python uses for classes is the word self. Yeah. But you'll find that this paradigm is pretty much in every modern language. The idea of writing classes, encapsulating and containing all of the logic. And let's go ahead and just see. Let's see. Does anyone else have a dog in here? No other dogs? Bailey, you have a dog?
I do.
What is your dog's name?
Daisy.
Okay, so let's say her dog is dog, and let's go ahead and name it Daisy. And how old is Daisy?
She's 3.
She's 3. What kind of dog?
Yellow lab.
Yellow lab. What kind of shares count?
Miniature Schnauzer.
My Riley was a German Shepherd. So anyway, so then you can see right here, like if we were to do her dog and then do .sit, now when we run this, we can see Riley and Daisy are both sitting. So it's one of those things, instead of instead of having to write a bunch of different functions and defining different variables, we just go ahead and initialize a class and store it in a variable. Okay, So just to take a moment as a little bit of an exercise, define a method to simulate a dog rolling over. Take a moment and just kind of parse the syntax that we've been working with, and suppose you wanted to write a method where the dog rolls over. All right, so again, fairly simple implementation. I just wanted to give you some time to kind of parse the syntax and understand kind of what's going on, but here's my implementation of the said method. Any questions on this so far? Okay, so let's see what I want to say here next. Now, like I said, as you're developing a class, it might be like, oh, okay, you're just kind of developing in here, but maybe you really want to work with the dogs. And by the way, just to make sure my implementation is correct, I'm going to just say her dog and click .roll over, and I'm going to go ahead and run that. And yeah, Daisy rolled over. Good job, Daisy. You earned a treat. Now, like I said, classes are nice to have contained kind of off to the side. It makes it very modular. So I'm going to cut this code and move it over to dog.py. So I just moved that over to dog.py. Notice that there's nothing in this dog.py. If I were to go ahead and run it, like if I were just to do Python and then do dog.py, nothing's going to happen because everything in here is basically just defining the class. But so this is a nice way to kind of separate logic from actual action. So what I could then do in main is just from the lowercase dog, which is the module or the file, go ahead and import capital dog, the class. And now if I run this, you can see it does exactly the same thing as before, but this is just an example of how you modularize code as you build bigger projects, as we maybe get to project 7, which is going to be where you may have a couple different things happening. It might be nice to be able to separate your code into different files to make it easier to find instead of scrolling through thousands of lines of codes. I don't know if yours will actually be that long, but so that's a little bit on the basics of writing a class. So let's go ahead, now that you've had some time with the syntax, so let me go ahead and give you a little bit of an exercise just to see if some of this is sticking. So the exercise will be right here. So let's go ahead and consider eating out. Eating is one of my favorite things to do. So you might want to just comment this out if you want, but the next exercise would just be to essentially, let's do another class. Let's call it restaurant, and read through this and see if you can go ahead and do something similar to what we just did with dog, but with just a little different context with restaurant. So let me give you 2-3 minutes there. If you have an issue, if you have a question on anything, feel free to ask. On the screen, I have my implementation of it. So again, make sure when you define a class, you just use the keyword class and then you define it. The convention is that classes are defined using a uppercase. You can put a docstring on a class right here. I don't think we had on the previous one, but one function that you can always go ahead and that's a special one is a dunder method, which is the init. And this restaurant name and the food type are the ones that actually, this was a little typo right here. That should be food type. These are the ones that you pass in whenever you are declaring or initializing it. And of course, for all the other functions to have access to those attributes, you do need to basically declare it in something like, in some sort of self.attribute. So I have two functions or methods here, describe restaurant, which will simply say the restaurant serves whatever this was. I changed that to food type. And open restaurant, I will say that the restaurant name is now open. All right, so any follow-up questions? Anyone have any issues with that or anything that they need? Let's go, Alejandro.
What do you use title?
Oh, okay, so I knew there was something else I wanted to say earlier, I just couldn't remember what it was. Perfect, thanks. Okay, so suppose that the reason I use title right here is just remember what title does is it takes a string and it makes it title case. So maybe you want to protect the integrity of Palace Pizza. I mean, has anyone gone to Palace Pizza? That place is amazing. So when you're defining it, suppose like whoever is typing it just is like, I don't know grammar. But you want to make sure that as you do different things with the class, that it prints in it in a way that is actually correct. So you actually have, so I've kind of hidden this right here from the user. Like you can imagine like this restaurant. I always have a hard time spelling that word, restaurant. Like maybe you have that over here in restaurant.py. We'll move it here in a minute. But if I run this, you can see down here after I bring it up, it actually went ahead and fixed the string to be title case. So basically, I am kind of enforcing and hiding certain things from the user of the class, which that's where we're kind of going into next. Does that answer your question there? Yeah, it's basically I am correcting the user of the class. All right, any other questions? Yeah.
So in our second two functions, why do we use self again?
In these right here, why do we use self?
Yeah.
Okay, so if we don't, so in this open restaurant function, we actually wanted the name of the restaurant to be used right here. So that restaurant name is stored in an attribute that we set up in the init method. if we don't pass in self, notice that this function all of a sudden does not, well, even if I just tried to do restaurant name right here, like if I just took all the selfs out, there is no variable called restaurant name in the scope of that function. So that self basically is a way to pass around attributes to different methods in the class.
Okay.
So, all right, any other questions? Okay, so this open restaurant is it's one of those things that, like, okay, how do I check if it's open? Maybe this is a little bit different from my notes, but I think it follows naturally. So this is me just kind of making this up on the fly, but here we go. But what if we want to just basically, what if we want to check if the restaurant's open? You know, like you have a phone call, let's check if open. So we're gonna pass in self, but okay, so if the restaurant is open, like, do we want to pass that in, or do we want to have some default value? So suppose, like, hey, it's Palace Pizza better be open. So what I'm going to go ahead and do is define in self. By the way, does everyone have some restaurant class similar to this one that they're confident that they can use, or should I go back to dog? We're fine here? Okay, so let's define another attribute. Let's go ahead and just say is open. And let's give it a default value. Let's call it true. Let's say Palace Pizza by default is open. So, you know what? Actually, it'll be better if we say it's closed. Is open, false. It is closed. So when we open the restaurant, we say it is now open, but if we go ahead and notice that there's no logic in here actually to open the restaurant. So we can actually also go ahead and do self.isOpen is equal to true. And then let's think about what do we want to do in this new method down here that we're defining. We want to go ahead and just if self.isOpen, so if it's true, print, we'll just say the f string, self.restaurant, I've got to put open press, self.restaurant name, and we'll just keep this title convention going, whether you do that or not, it's fine, is open. And the other scenario, so else, print, I'll just copy and paste this down, and I'll just go ahead and say is currently closed. So again, let me put self back right here. So you can see right here what we have done is we have another method that's going to check if the restaurant is open, and it's going to access some attribute by default. And again, notice that we did not initially say when we initialize this class if it is going to be open or not. We're just say it's going to start closed. So now let's go ahead and see if this function works. So Palace Pizza, food type, and I'm going to go ahead and do pizza place dot check if open. Then I'm going to open the restaurant, and now I'm going to go ahead and do check pizza place dot check if open, and let's run this. And you can see right here, the first time it is currently closed, but then we ran the open restaurant. And again, maybe just to make this I'll just say is opening, because it's the action of opening the restaurant. And then the check if open, the second time we called it, it ran the first part of the branch because it is true. So you can now basically encapsulate the logic and contain that logic within the class, and then just act on it or access it down here below. So that's another thing that we can do with object-oriented programming classes. Yeah, Anna.
Did you assign it false somewhere?
So did I assign it false? Yeah. So again, when I initialized it, I chose to initialize it as false. Notice that this false right here is just the default value. When I actually initialize the restaurant. I did not like have a parameter that said whether it was open or not. Okay. So let's go ahead and just kind of keep practicing this a little bit. Any other questions? Yeah, Kenneth. So remember that these are functions. To call a function, you do need the parentheses. So one thing that you might run into is if you forget to put parentheses, and maybe just if you're curious, these right here, let me just print check if open, and you can see right here, I printed without calling it. So this, and remember I said methods are basically tied. I guess the terminology being used in Python is bound to that restaurant. So again, if you don't call it, that function is actually an object somewhere in memory that is just going to print that. So, any other questions? All right, so let's go ahead and do another class, just good practice. So I'm going to go ahead and erase this. I'm going to go ahead and move this logic over to a my restaurant.py file, and let's see where I'm at. So I'll go ahead and move this exercise over. I'm just basically resetting. Anyone in, I don't know, I had a friend in high school. His name was Michael. We called him Keebler because there was two Michaels, and one was tall and one was short. So you can guess that the one we called Keebler was the short one, of course, because it was a reference to Keebler Elf. In hindsight, terribly mean, but he liked the nickname. All right, so what did that have to do? Oh yeah, he liked cars. Anyone in car fans in here? Okay, this example might miss a little bit, but it has a few good scenarios. So let's go ahead, and I'm going to just go ahead and reset main right here. And let's go ahead and define a car class. So what is the keyword we use to define a class? Well, the keyword is class, and we'll call it car. And then when we initialize it, we'll go ahead and init self. Okay, so let's see if we are. Oh, I forgot my def. So def. All right. So what are some things that we typically talk about when we are talking about cars? Brand. Okay. Make, model, year. Typically, make, year, and model are the things that come to my mind. So how are we going to do that? We're going to need make, model, year. And again, these three variables are going to be passed in when we initialize the class, but we do want to go ahead and store them in self. So self dot make is equal to make, self dot model is equal to model, and self dot year is equal to year. And just to make sure this is playing out correctly, I'm going to go ahead and declare a variable called myFirstCar. It is of course, it was a car. It was a Chevy Lumina. Lumina. And 1994. Yes, my first car was a 1994 gold Chevy Lumina. My sister made fun of me because she said nothing says old like gold. Anyway. So if we go ahead and run this, of course, nothing's going to happen because I've just initialized it. And let me kind of piggyback off of that little error that you ran into a moment ago there, Kenneth. So remember, attributes are not functions. These are just like, for example, what is make? What is the data class of make? You can see it right here. It is a string. What is the data class of what is the model? It is also a string. And by the way, what is the year? What type of data is that being passed in here? That's an int. So, by the way, again, you can also we're not necessarily doing it, but if you like really wanted to enforce like certain requirements, you could add some type checking. So you could add like type checking. So like you may want to say something like if I'm not gonna. Okay, that's just getting too complicated. But like you can do like is instance. It's just another thing that is very convenient with classes that you can hide type checking from the actual user of the class. It just breaks up responsibilities. Okay, so if you wanted to, you can go ahead and print my car, my first car, and let's say I wanted to know its make, and let's just run this and notice right here. I am not actually using the parentheses because it's not a function I'm calling. It's a string. It's an attribute. So does everyone understand the difference between attributes and methods? So attributes are like some sort of data type that you don't need parentheses. I think it'll actually yell at you if you do. It'll say it's not defined. Yeah, so it's saying that string is not callable. So it's not a function, it's not a method. Okay. So, but like, what happens if I were to just print my first car? Like, let's suppose you're writing a program and you click print my first car and you get something like this. Like, okay, cool. It is a car object and this right here is just some location in memory. So what did you expect it to print? Like if you were to just print my first car, while car is not necessarily a data type that we've been working with, what would you think it should print if you just wanted to print my first car?
All three attributes.
Yeah, I would say, if someone asks you what's your car, I drive a 1994 Chevy Lumina. So what I really wanted to do, what I could do is there is another dunder method, and it's called str. So what this is doing is, and you can even, is going to return the string form of your class. So if I call print, print is going to say, okay, does this object have a string representation? So of course it's going to need self. And what I want it to do is return what I want it to print. I'm going to have it return the self.year. But remember, self.year is an int, so we do want to go ahead and cast this to a string, 1994, and then I'm going to put a space, and then I'm going to do self.make space self.model, and then end this. So now what you can do, when I run this, you can see you have like a custom representation of this class, so that whenever another function needs the string representation, it'll go ahead and just look to see if a double underscore str, a dunder str method is defined or declared in that class. Okay. So, any questions on what's happening there? So maybe as a little bit of an exercise, do you all know what an odometer is? I'll just say it. Odometer just tells you how many miles are on the car. So as a little bit of an exercise, add a odometer, and write a method to set the value of the odometer. I'm going to give you maybe a minute to think about that. So add an odometer, or I guess grammatically I should say an odometer, and write a method to set the value of it. Maybe as an extra challenge, do not add any parameters to the initialization of the class. So, an odometer is basically telling you how many miles on the car. So a new car is going to have an odometer set to 0.
So you want us to do it without just adding it to the...
Don't add anything here.
Okay.
hint one if you're struggling. We have about 5 minutes left. Here, let me do this. Pair up with one person next to you. So Alejandro, maybe step up with Bailey or vice versa, and see if you could work on this together. Maybe one of you know exactly, like, see if, just maybe talk it out a little bit if you're struggling. So pair up next to each other, and let's see if you guys can make some progress.
Ask the user, or you want us to pass it in as card?
I mean, you don't have to ask the user. That would kind of come in the actual bottom part. I just want you to write the functionality so that this class has an odometer and set the value of the odometer using some sort of method. So I'm not necessarily asking you to do it. I'm saying write the functionality so that if someone wanted to do it, they could.
So is the value of the odometer like given to you, or are you making something, right?
Well, I mean, if you were actually implementing it, yeah, then like, let's say like you get a car and you're like entering the inventory, so you initialize like a new object in the inventory, and then you have to set its odometer. So it's like your system should be able to be like, oh, there's a method that allows me to, as I enter this, like you just initialize it with the year, make, and model, and then later you want to be able to call a method that will set the odometer reading in the inventory.
Well, no, because we needed to be able to call it, so you need one. When you mean change it, like put it to one, why odometer, or just like change it.
Well, and again, this would maybe be the extension of the exercise. Like, do you want to restrict it? Like, can you have a negative reading on the odometer? Should they be allowed to decrease it? Things like that. That would start kind of being the extension of this exercise. Right now, just like, yeah, give the car an odometer and write a method that allows you to set the odometer. Let me give you about 90 more seconds to play with it. Do you all want the answer before you leave? Caroline's like, please. All right, let's go ahead and take a look at the answer and see if your implementation is something similar to mine or if it follows logically. Okay, so, and I also am going to kind of answer your questions like, do I need to ask the user for it and things like that? Again, I just want to give the user the possibility or the option to be able to set the odometer. So what I'm going to do is first, when I initialize the car, I'm going to initialize it and just say the odometer has a reading of 0. And then what I'm going to do, if I want to change that, I'm going to define a method, and I'm going to just call it set odometer. By the way, there's a common programming paradigm known as getters and setters. So what I'm doing here is defining a setter. So I am going to set the odometer. It needs to take in self, so it has access to the class attributes. And it is going to take in some number, or so we'll just call it some mileage. And what I'm going to do with that is I'm going to take self.odometer and set it equal to whatever the mileage is. And there's a couple things that we want to be careful of here. First of all, let's see if this does what it expects. So if I go ahead and print my first car dot odometer, and I go ahead and run that, I can see that there are 0 miles on that. Is everyone okay so far with where that came from? But now what I'm going to do is I'm going to go ahead and do my first car dot set odometer, and I think I got rid of the car. I think it was around 100,000 miles when the brakes were just making some terrible noise that felt like it was a death trap. So now if I do this, I'm going to go ahead and print the odometer again. So my first car dot odometer. And you can now, if I run this, you can see that the second print statement, or I guess the last print statement, it is now 100,000 right there. So maybe one more thing just to emphasize the importance of self, but any questions on that? What if you forgot to use self? If you forgot to use self, let's think about what this is doing. A is telling you the local variable odometer is assigned and never used. If you don't use self, this odometer only exists within the scope of the set odometer function. So if I run this, what do you think? Does anyone think they know what the second print statement is going to be if I remove the self? It's going to be 0 because it never updated the attribute. Like I said, self is kind of those things that take a while to get, but it allows you to access the attributes or the properties of your class. So if you don't put it here, that odometer is only in the context of, or the scope of that set odometer function. So we do want self there. But that's a good introduction to object-oriented programming. We still have to talk about inheritance. And that's what we'll start on next class. Any questions? Yes, sir.
Put the underscore instead of comma.
Say again? Oh, right here. So this is just remember that in Python you have a kind of the option. If you don't put it, sometimes like the zeros together makes it hard to read. So in Python, if you put a underscore, it acts as a comma. You don't want to use a comma because then it would think that it's 2 separate arguments to the function. So that's why I used that underscore right there. Just it made it so I put 100,000. It was just I lost track of the zeros. Any other questions? All right, very good, everyone. Remember that the LaTeX project is out. If you have any questions, let me know, and make sure you're kind of thinking about what project or what concept you want to present for your little part 3 and 4, and get signed up if you have something you're really passionate about. Have a good day, everyone.